So to solve this problem, we must first use a sketch to see how the pairs of vertices form the sides of the quadrilateral. So we can hypothesize this appears to be a parallelogram, but we have to use calculations in order to prove this. So, like in the previous example, we'll first look at the lengths of sides. So we'll set up four formulas for sides AB, BC, CD, and AD. Then subbing in for side AB, -2 subtract -6 squared plus 6 subtract -4 squared. -2 subtract -6, -2 plus 6 is 4. 6 subtract -4 is the same as 6 plus 4, so that's 10. 4 squared is 16, 10 squared is 100. Adding them together, we get that side AB has a length of the root of 116. For side BC, 6 subtract -2 squared plus 8 subtract -6 squared. So we get 8 squared plus 2 squared, 64 plus 4. So side BC has a length root 68. For CD, 2 subtract 6 squared plus -2 subtract 8 squared gives us -4 squared plus -10 squared, 16 plus 100. So side CD has a length of the square root of 116. Finally, side AD, 2 subtract -6 squared plus -2 subtract -4 squared, 8 squared plus 2 squared, 64 plus 4. So the length of AD is the root of 68. So since opposite sides are equal length, AB and CD are both root 116, BC and AD are both root 68, we know that this is either a rectangle or a parallelogram. Now we have to look at slopes. You should note two things. One, our points are given up here, so our x1, x2, y1, y2 are simply taken from the vertices given A, B, C, D in the question. Also, there's no need to actually take the square root on your calculator since we want the exact values and not the decimal approximations. So now looking at slope, we'll set up four slope formulas, one for each side. Subbing in AB, 6 subtract -4 over -2 subtract -6. So this becomes 6 plus 4, which is 10, -2 plus 6, which is 4, which reduces to 5 over 2. For BC, 8 minus 6 over 6 subtract -2 becomes 2 over 8, which reduces to 1 over 4. The slope of CD, -2 minus 8 over 2 minus 6, that's -10 over -4, which reduces to 5 over 2 for the slope of CD. Finally, for the slope of AD, -2 subtract -4, 2 over 2 subtract -6 becomes 2 over 8, which reduces to 1 over 4. So opposite sides are parallel. BC is parallel to AD. AB is parallel to CD because they have the same slopes, but the adjacent sides are not perpendicular. 5 over 2 is not the negative reciprocal of 1 over 4. So therefore, this quadrilateral is a parallelogram as we hypothesized because opposite sides are equal length and they're parallel, but the adjacent sides are not perpendicular. So now we need to look at the midpoints of the diagonals AC and BD. So first we'll find the midpoint of AC. So we use our midpoint formula, sub in from the vertices given. So -6 plus 6 over 2, -4 plus 8 over 2, gives us 0 over 2 and 4 over 2. So the midpoint of AC is the point 0, 2. Finding the midpoint of BD the same way, we write our formula, substitute in -2 plus 2 over 2, and 6 plus -2 over 2. Gives us 0 over 2, 4 over 2, which becomes 0, 2. So we see that the midpoints AC and BD are the same. Therefore, we could say that the diagonals of the parallelogram bisect each other, since they meet at each other's midpoints. So in the previous examples, you showed that the midpoint of one diagonal of the square lies on the other diagonal. You also showed that the diagonals of the parallelogram bisected each other. These are properties of quadrilaterals that hold true in a general case. That means the midpoints of diagonals of the square always lie on each other. The midpoints of the diagonals of parallelograms always bisect each other. So if we go back to our relationship between the types of quadrilaterals, remember squares are a special rectangle, which are a special kind of parallelogram, which are a special kind of quadrilateral. As well, all squares are a kind of rhombus, which are a kind of parallelogram, which are a kind of quadrilateral. So this interesting relationship means that if the diagonals of parallelograms bisect each other, then the diagonals of squares and rectangles and rhombuses all bisect each other, since they're all special types of parallelograms. So now I'd like you to complete the Geometer Sketchpad activity on your worksheet to help illustrate two extra properties of the diagonals of rhombuses and squares.